Good afternoon or morning, everybody. Okay, so we're into using these trigonometric identities, Pythagorean identities today. And it says use the Pythagorean identities rather than reference triangles. Well, back in chapter 4, which was right toward the beginning of the semester, we would use reference triangles for something like this, where we would have, for example, tangent equals 3/4. We'd be able to work backwards and find all the sides and everything about the triangle, right? Well, here we're using the Pythagorean identities, and the main one we have here is this one. And speaking of trigonometric identities, does anybody need one of these formula charts? So this is our first main Pythagorean identities. Anybody need to have one of these formula charts that has these on here? Okay. Yeah, this card stock. Anyone else? Anyone else? Here we go. All right. Pythagorean identities. And for those of you who weren't here yesterday, we talked about where Pythagorean identities came from. And they came from the Pythagorean theorem. Isn't that strange? And this is the drawing we made of it, that if you have a point somewhere along a unit circle, you have an xy coordinate pair, which is going to be cosine theta, comma sine theta, and that if you square both of these sides, you're going to have equal to c squared, which is 1 squared. And so here's where you get the main Pythagorean identity, and then you develop from that identity these other two. And these here are all in your ACP formula chart that are there for your use. All right, so that's the basic Pythagorean identity. And so I want to kind of take you through number one. I'm going to kind of share. I'm going to choose some people to help out with some of these others. And I realize that not everybody here is ready for everything right now. And so we're all, each one of us, kind of a work in progress. So anyway, you have find sine theta and cosine theta if tangent theta equals 3/4 and sine theta is greater than 0. So what would you do with this thing here? Well, the thing I would do is this. I would go to this trigonometric identity right here with tangent in it. Do you see that? So we have a 1 plus tangent squared theta equals secant squared theta. And one thing I didn't say today yet, that I said yesterday, is this notation. This tangent, when you say tangent squared theta, what you really mean is you mean that you're squaring the whole thing. Okay, so this is just on the left accepted notation for squaring the whole thing. Does that make sense? It's just something you have to get used to, and it's not going to be that hard. So anyway, now we have our revised trigonometric identity right here, and we want to find secant theta and cosecant theta if tangent theta equals 3. I wanted to go to number 1, didn't I? Yeah. Let me go to number 1. Here we go. This is number 1. Somehow I got lost. So here we have find sine theta, and so we're going to have, again, this one right here, 1 plus tangent squared theta equals secant squared theta. Okay, and we are given already something, aren't we? What are we given in here? Tangent. So I'm going to write this as 1 plus tangent squared theta equals secant squared theta. Okay? So what can we do to solve this equation now? Yeah, so we have this here. So we have 1 plus, what's 3/4 squared? How about 9/16, right? So that's going to be our secant squared theta. And this thing right here is going to be 16/16. So we have 16/16 plus 9/16 is equal to secant squared theta. What now? Yeah, so we have 25/16, right? Equals secant squared theta. Okay? What now? Yeah, so square root, I'm going to come up here like this. So we have secant theta is going to be equal to plus or minus the square root of this guy here, which is going to be 5/4. Is that right? So 5/4. And we're already said, let's see, we don't know that. We want to find cosine theta. How do we find cosine theta? Yeah, so cosine theta is going to be equal to plus or minus 4/5. And there's our cosine theta. And it says, how do we figure out which one is which? Tangent theta is 3/4. Sine is greater than 0. What does that mean? Well, it means this is positive. So here's our cosine theta. Okay, how do we find our sine theta now? You could. Yes, you could do that. In fact, there's another way that might be a little easier to it, but since you suggested it, I think that's what we do, right? Let's go with what we got. So here we have sine squared theta. We don't know what it is, but we know that cosine theta is 4/5. So we have plus 4/5 squared is equal to 1, right? So what is this going to give us here? Sine squared theta plus (16/25) is equal to 1. I'm going to call 1 25/25. So what are we going to get here when we subtract out? 9, huh? So sine squared theta is equal to 9/25. And so what is sine theta going to be? 3, yeah, plus or minus, but we know it's going to be what? Plus. So 3/5. Okay, so now we have sine. We have cosine. So we have everything, right? Now, one thing that, who sent me down this path? Was it, okay, it's Emily, good job. And what happens is you got another thing that could help you out, is you have tangent theta is equal to sine over cosine. And so what you have is if you know, if you want to find sine, you can take your cosine, which you have here. So you have tangent, which is 3/4 equals sine over 4/5, and just multiply that out, and you'll get 3/5 when you do that. So.
What you do, like tangent is opposite over adjacent, and cosine is adjacent over hypotenuse, and then you can just.
Yeah. So what that becomes, and so what she's talking about is this. When you simplify everything out, you ended up having a quotient identity like this. And if you go ahead and put tangent, like you said, sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse, you cancel out to eventually have opposite over adjacent. But that's what this is. So this is like tangent equals sine over cosine. That's like m equals rise over run. Okay, how much you increase. So these are your quotient identities, and these are not on your formula chart, but you can scratch them into your formula chart here, your quotient identities. Okay, you do that. And after you do that, I want you to look up number 2, and we're going to go over that and talk about those identities here. Yes.
But all of that, or just the part?
Yeah, this part right here, this is already in your ACP formula chart. These right here are not. Right. You see these here, don't you, someplace? But probably not these. So are you working on number 2 right now, I hope? And basically the ones we're working with in this section are the Pythagorean identities, the quotient identities, and the reciprocal identities. And then we use those and simplify and get to something, okay? How many feel like they're making some headway on this, on number 2? Anyone? A little bit? Not? Yeah, a little bit. So I have a couple people saying, yeah, a little bit. Other people, I know sometimes you guys have some good confidence levels going on that are sort of under the surface. But just whoever I call on, just be ready to work on this, and we'll just kind of work through it, okay?
Can you go back to the formula?
This one here? Or this one here?
That one's fine.
These are fine? All right. So let's go to this. I'm going to choose somebody here. Yeah, Angel's not here today. We're going to get Kayla. Okay, Kayla, we got you here. Kaylee, we got you. Kaylee, we got you. What do you think? Okay, yeah, sure.
Is the cosine plus or minus 1 over 5?
She asked, is the cosine plus or minus 1 over 5? Yeah, I don't know. Okay, secant. So you talk about this one here. So we have 1 plus tangent squared theta. Well, that's going to be 3 squared, right? Equals secant squared theta. Okay, I think she's kind of on the right track here. So what does this simplify to? 10, right? So 10 equals secant squared theta. So what is your secant theta going to be? Okay, so it's going to be plus or minus square root of 10, right? So really we found secant theta, except it's going to be plus or minus here. Okay, we're given cosine is greater than 0, tangent is 3. So what is this going to be, plus or minus? Okay, I don't see any negative signs here at all. So everything here is going to be plus. So here's your secant theta, right? And then we want to have cosecant theta. How do we find that? Okay, reciprocal of what? Cosecant theta is going to be reciprocal of sine, right?
I'm confused. Because on here, you had us turn.
Does it ask for cosine? This one doesn't ask for cosine.
Yeah, so anyway, basically, it's cosecant, and we know that's going to be 1 over sine, right? I don't know how much that helps us. We have this thing up here. We have the other trigonometric identity, don't we? We have this one. We have 1 plus cotangent equals cosecant. Well, we have that.
That's what I did.
Really? Okay. So 1 plus cotangent equals cosecant. Let's look at that one. So 1 plus cotangent theta equals cosecant theta. Cotangent squared theta, right? Yeah. So we have that. And so do we have cotangent here? Yeah, we do. All right, so we have 1 plus cotangent is going to be 1/3 squared, and that's going to be equal to cosecant squared theta. So what's this going to be over here? 1 plus 1 plus 1
Oh wait.
9.
1/9, what you can change from 1 to 9/9.
Yeah, so it'd be 9 over 9. So that's going to be 10 over 9, right?
Yes.
9, 9. So 10/9
The square root of 2/9.
is equal to cosecant squared theta. Oops. And so therefore, cosecant is going to be what? Yeah, cosecant theta is going to be equal to the square root of this. And it's all going to, is it going to be plus? I think everything's plus here, isn't it? So it's going to be equal to square root of 10 over 3, is that it?
Yeah.
Okay, so again, to me, not the easiest problem in the world, but you start working on this and start thinking through these things, and you'll get some places. So I want you to work on number 3. I'll choose somebody to help us in a minute on 3, okay? I don't know about you, but do these things make you have to think, kind of,
Yeah.
where things are? They really do to me. These are challenging things here, to me. Let me have this. I got those forms filled out too.
Yeah, I was about to jump.
Okay, so they're all probably, so I get very tight. But you guys like had 25 applicants for varsity. 29? That's a lot.
Yeah, since 15 tried out last year. for varsity.
That's just a lot. But it's good to be popular. It's good to be a part of a group that people want to be in, I guess.
I don't know about popularity. Especially if you like doing.
Okay, next. What I did is I kind of, let's go ahead and call somebody here. We got Hannah or Kinsey. It's going to be Kinsey, all right.
Yeah, it is.
All right, Kinsey. What do you think?
I think it should be Hannah's. She was here yesterday.
I'll do it if you want me to.
I would definitely let you do it.
Who are you nominating?
I'm nominating Hannah.
Hannah?
Because I'd rather not.
Hannah, do you stand to be nominated?
Yeah, I'll do it.
All right, Hannah, go ahead.
I see your ankles.
So I did the formula where it's 1 plus tan squared equals SEC squared, but
1 plus tangent squared equals SEC squared, okay.
yeah. And then I put 4 squared as the,
So 4 squared goes right here?
yeah. And I got x squared equals 15, so I got x equals the square root of 15, which is tan theta is the square root of 15.
You put right here. So that's going to be 4 squared, that's going to be 16 is what? Yeah, 16 equals 1 plus tangent squared theta, okay.
Yeah.
So you,
So
that's tangent.
subtracted, and so then it would be tangent square theta equals 15.
Equals 15, okay.
And then you square root it. I got the square root of 15.
You got positive 15?
No, it's gonna be negative since it's less than.
Well, because the sign is less than, so that's going to be a negative. Okay, that's good. Good work. Okay, what next?
And then cotangent is the opposite of it. So I did, or like the reciprocal, so I did 1 over the square root of 15.
So basically you have your answer here, and your cotangent theta is just going to be like negative 1 over square root of 15, is that right?
That's what I got.
Okay. So that's it, isn't it? Is that hard? I think this one here might be a little easier than number 2, but still that's good work. All right. That's some good work.
Was it just hard?
So we have just one more, problem 4, right? So you can do problem 4.
I understood it and I wasn't there for it.
You guys, you trigonometric identity geniuses, if I may call you such. All right. That is some good work right there. Okay. I think this one here, I think in 5th period, I think Karina got called on to do this one. But I'll call on somebody else. And Angel is not making it here today. What happened there? So Carmen, okay, basically we have this, right? So which trigonometric identity would you use, or Pythagorean identity? I would use this one here.
She got it.
Is equal to 1. So now, if we substitute in for cosine, what do we have here? So, by the way, I'm remembering some of this from 5th period. So we have sine squared theta plus that's going to be 0.64, right? Equals 1, and subtract out. So 4, that's going to be 3/6, right?
Yes.
1 minus, so it's going to be 0.36. And so sine theta is going to be what?
0.6. 4 3/5.
What's going to be, it's going to be it's going to be 0.6, right? Or it's going to be 3/5, right? Yeah, 3/5. So that's going to be your sine theta, your tangent theta, here's your cosine theta, your tangent theta,
So now 3 is going to be on top.
yeah, your tangent theta is going to be your 3/5 divided by 4/5. So we have this 3/5 times 5/4, which equals 3/4. And so here's our tangent theta equals 3/4. Here's your sine theta equals 3/5. So that's it, isn't it?
Wouldn't they be negative though? Yeah, they're negative.
Let's see, because tangent theta is less than, so that is going to be negative. And sine theta, well, cosine is positive, so this has to be negative, so they'll be negative, negative, you're right. Okay? That is some good work. And really gets us to the end of class. So we're going to go ahead and next